decimals, fractions, and percentage unit. This lesson has to do with adding, subtracting, multiplying, and dividing decimals. So adding, subtracting decimals, pretty straightforward. When you're adding or subtracting decimals, we write the numbers under one another so that the decimal points are directly underneath each other, okay? So we do this so that the digits in each place value also lie under one another. So if you look at this example here, 1.76 plus 0.961, okay, your place value of 7 and the place value of 9 are in the same spot. So we want to line those two up here, okay? Same with the 6 and the 6. And then this 1, but there is no number here, so we put a 0 there just to make sure that we're all lined up. And if you notice, our decimals are in a direct line here. When we add those, 0 plus 1 is 1, 6 plus 6 is 2. Carry the 1. In this example, they put it down here instead of up here. You can put it either spot. So now we've got 17. Again, we carry the 1 and 2, bringing our decimal directly down to 2.721. Again, over here, these are subtraction ones. 4.632 minus 1.507. Notice again that our decimals are in direct line with each other, and you just subtract as normal. Okay, so for this one with the 8 minus 0.706, 8 is a whole number, and so the decimal will come after the 8, and then you add zeros to make up the place values for the 0.706, and then again subtract as normal. So front-end estimation is just another quicker way to add and subtract decimals, and you can check to see if your answer is reasonable or get a quick idea of what the answer will be by estimating. So front-end estimation, very simple. You simply take the whole number of the decimal and add them together. So for example, 4.5 would just be 4, 8.12 would be 8, 2.45 would be 2, so you get 4 plus 8 plus 2, and you're estimating that your answer is about 14. And remember that when you estimate, you always preface your answer with the word about. So you can also round to the nearest whole number for this. So if in this case it would have been 5, 8, and 2, which would have given you about 15. Either way is an reasonable way to estimate. However, when you're asked to do front-end estimation in particular, there is no rounding. It's just the exact what the whole number is. So multiplying and dividing by powers of 10. This is pretty simple stuff. So multiplying by powers of 10, so 10, 100, 1,000, 10,000, etc., etc. Okay, so pretty easy to arrive at. If you have 0.45 times 100, the 100 is essentially 10 to the second power, right? So 10 times 10 is 100. 10 times 3 would be 1,000. So 10 to the third is 1,000. 10 to the 2 is 100. So you would move that decimal place 2 spots to the right. So 0.45, move 2 spots, 1, 2, becomes 45. This is what you're doing when you convert decimals to percentages. So if you have a 0.483 as a decimal and you want to find the percentage, because percentages are out of 100, you would just move it 2 spots, and that would be 48.3%. Okay. So if we look down here, and you have all of these different examples. So 10 to the 1, we're moving 1 spot. 10 to the 2, we move 2 spots. 10 to the 4th, we move 4 spots. So pretty straightforward stuff. When you're dividing by powers of 10, you essentially do the exact opposite. You move your decimal to the left instead of to the right. Okay, so 0.0037 divided by 100, again we have 2 zeros, so we move 2 spots this way, and we end up with 0.037. By 1,000, move 1 more spot, we get 0.03. By 10, we only move 1 spot, so we get 0.37. When we so you can turn this into an algebra statement by saying when you're dividing by 10 to the nth power, we shift the decimal n places to the left. So that number, because 10 to the n times smaller than it was originally. Okay, so every time you move to the left, you're making a smaller number. And when you're doing it by tenths, it's becoming that much smaller every time. Multiplying decimal numbers. So when you're multiplying 2 decimal numbers together, you multiply it as if they were whole numbers, then just move the decimal place to the left, the appropriate number of spaces. So for example, 5.6 times 3.2 would be set up like this. 5.6 times 3.2, then we do the multiplication. 2 times 6 is 12. Carry the 1. 2 times 5 is 10, plus 1 is 11. 3 times 6 is 18. Carry the 1. 3 times 5 is 15, plus 1 is 16. Add them up. 2, 9, 7, 1. Then we have 2 places, so move that 2 spots. So your final answer would be 17.92. Now, powers of 10 come into place here as well. So even though we count, we've got 1, 2 places behind the decimal. These are both tenths. So a tenth and a tenth is essentially 10 to the 2. So we know that we need to move it 2 spots, just like we did on the back over here, okay? 2 spots, we moved 2 spaces this way, okay? So dividing decimal numbers. When you're dividing a decimal number by a whole number, you carry out the division as normal, writing the decimal points under each other. So if you have 32.5 divided by 5, it would be set up like this. And I couldn't. Okay, so 32.5 divided by 5, and then you do it as normal. 5 goes into 32 6 times. That'd be 30. With a 2 left over. Come down to 5, 25. 5 decimal goes straight up. Okay, so your answer would be 6.5 because this decimal goes straight up that way. Okay, when you're doing a decimal number by a decimal number, you have to convert the divisor to a whole number, making sure to move the decimal and the dividend the same number of spaces. So if we've got 35.524 divided by 0.53, we have to make 0.53 a whole number. So we move our two decimal places to make it a whole number, but because we did that, we have to move this one 2 places. Okay, so our new number becomes 3552.4 divided by 53. And again, you would set that one up like this. Okay, and wherever your decimal ends up, you bring it straight up, and that's where your new decimal goes. Okay, so however many times 53 goes into 3,552, and then you do your remainders, bring down your 4, and once you bring down the 4, that's when you're going to be working on the other side of that decimal. Okay, so just remembering that when you're multiplying, your decimals are going to the right, and when you divide, your decimals go to the left. The reason these ones go to the left is because this is essentially a division, right? So you're doing the multiplication and then you're dividing by 100 or 1,000, however many zeros you have here, to get that decimal back where it's supposed to be. Okay, with this one you're doing the exact opposite. Okay, you're multiplying it by base 10s to get it over. So this one you would have to multiply by 100 to get it 2 spots. Okay, this one then you would have to multiply by 100 to get it to go 2 spots, and that's why your decimals go this way. Go to the right in this case and to the left on this case. All right? So hopefully that makes some sense. We'll do some more work on this in class, and we'll see you next time.